So next topic is differentiating ln x and e raised to power x. As you can see, the two formulas for log x and e raised to power x are the derivative of ln x, which is just a natural log whose base is e, right? So log x with base e is written as natural log. So derivative of log x is 1 upon x and derivative of e raised to power x is e raised to power x. It is more interesting because it says that e raised to power x is a special type of function whose gradient changes according to the function. As the function is changing, accordingly its gradient is also changing, right? The derivative of these two functions, derivative means not derivative, I will say the derivation of these two formulas, these are derived from using the first principle of differentiation. First principle means it involves the basic definition of differentiation which Newton gave, right? Using which the whole calculus, differential calculus, all the formulas of differentiation, they came using the first principle of differentiation. Why we say that it is the first principle? Because the basic definition of differentiation, mathematical representation of that definition, we say it is first principle. Okay, so for now you just remember these formulas, and there is no need to remember these formulas because these will be provided you in MF19, right? But when you will use MF19 multiple times, these formulas you will remember automatically, right? So there are more basic formulas, or not basic but the general formulas, that if dy dx of ln ax is given, where a is just a constant, okay, you will apply here the chain rule. What chain rule says? That you can assume ax as another variable t, right? So now the function is now in terms of t. So you first differentiate log x ln ax with respect to ax, that means t. I hope you can apply the chain rule directly, right, in differentiation. So dy dx of ln ax, you first differentiate this with respect to ax, which is 1 upon ax, and then differentiate ax with respect to x, which is just a. So a upon ax is nothing but 1 upon x. So derivative of log ax will again be 1 upon ax, right? But the case is not the same for e raised to power ax, right? So d by dx of, it is 1 upon x. So dy dx of e raised to power ax, suppose it is nothing but, you first differentiate this with respect to e raised to power ax, with respect to ax, sorry. So this is e raised to power ax, and then differentiate ax with respect to x. So it is just a, right? So coefficient will be multiplied in every functions except this log x. Okay. More generally, instead of this ax, some another function is given. Means log is a function of another function. Let us say ln 2x or ln e raised to power x or ln sin x or ln cos x, any trigonometric function. Means log is again a function of another function. So in that case, what should be the general formula for differentiating any function, not just log? Okay. So again, the chain rule will be applied, that you first differentiate the outer function. Suppose it is, let us say it is a composite function f of gx, and you are differentiating this with respect to x. So it says that you first differentiate with respect to gx and then differentiate g with respect to x. Okay, you first differentiate with respect to gx. What you need to differentiate? F of gx with respect to gx, and then differentiate with respect to x the inner function, which is gx. This is the chain rule. Okay, so this is just a summary of all these formulas, that y is equal to, if it is a ln x, then dy by dx is a upon x, since a is just a constant. This formula I have derived here, that applying the chain rule you will get 1 upon x. There won't be any multiplication of a in case of ln ax. Okay, so these are the two general formulas, that if it is ln fx, so what you need to do is you first differentiate log fx with respect to fx, right? So you will get 1 upon fx, as derivative of log x is 1 upon x. So derivative of ln fx will be 1 upon fx, and then differentiate fx with respect to x, denoted by f dash x. Okay, So this is your differentiation of ln fx. Similarly, same chain rule you can apply if it is in the exponential form. So if it is e raised to power fx, so differentiate e raised to power fx with respect to fx, it is just e raised to power fx, and then differentiate fx with respect to x, you will get f dash x. So f dash x into e raised to power x, right? So again, there is no need to remember these more three formulas. If you know how to apply chain rule, I think there won't be any problem. Okay,